So for 6.3, we're going to write and graph piecewise functions and use them to describe real-world situations. And for example 1, we're going to look at some movie data. First, let's talk about what a piecewise function is, right? Okay? So there's the word piece in there. It's like Reese's Pieces, right? Reese's Pieces are parts of Reese's Peanut Butter Cup. They're in the nice little bite-sized candies that E.T. likes. You guys seen the movie E.T.?
Oh.
He does. Yeah, so a piecewise function just takes different pieces from different functions and puts them together. Okay, so yeah, so there's different intervals that will model different situations. So it's a combination of one or more functions. A very common piecewise function that models real-world situations are going to be piecewise functions that look like these movie tickets here. Okay, so before we start talking about that, let's talk about the different equations we've studied this year. Yeah, quadratics, yes, that was a big one. So we've talked about quadratics. What else? Yeah, we've done logs, we've done linear, exponential, those are the most recent ones. What else? Yeah. Quartic, a little bit of quintic, yeah. Okay, so in a linear equation, what's the degree? 1. In a quadratic, it's 2. Okay, these are special. We also looked at the square root a little bit, briefly. We're actually going to look more at the square root in chapter 5. And so then we have the cubic, which was 3, and then the 4, 5. But what comes before linear? Yep. Guys, if you put your calculators away, we aren't going to need them today. Okay, so the constant. And what does a constant function look like?
A line.
Yep. Horizontal line. Okay, linear is either going up or down from left to right. Quadratic. Okay, exponential. And then your logs are like the reverse of that. All right, so what you can do is you can graph parts of each of these functions on different intervals. And this is useful when you are looking at different costs. Okay, so this book is a little bit older, as you can tell by the price of the movie ticket. Unless it's $5 Tuesday, right? Okay, yeah, I know. So if you look at the graph, you can see from 0 to, we'd have to estimate about what this is, and there's an open circle. Do you guys remember what an open circle means? Okay, yeah, so it equates to an inequality symbol, a less than or a greater than sign, and then if it has the closed circle, then it means what? Or equal to, okay? So it includes it, okay? And then we can write a table that models this. So from 0 to 12 years old, it would cost $5 for the movies. From 13 up to 54, $9. And then at 55 and above, $6.50. Okay? And then I do want to explain this. This isn't something that we're going to use right now, but your book does have this notation in it. See how that's a bracket? And this is a parenthesis? Okay, so if you have a bracket, that means it includes it. Okay, and then if you have a parenthesis, that would be an open circle. So it doesn't include that. Okay? All right, so we're gonna look at this, and then we're also going to be writing verbal descriptions. So when you're doing a verbal description, you're just describing what's happening in your table. Okay, so that just means for children that are 12 and under, right, the price is $5. For people that are 13 to 54, the price is $9, and then $6.50 for people who are age 55 and older. Okay? All right, so now we are going to do this with our given table, and take a second to look at the graph, okay? And define what's going to be your independent variable and what's going to be your dependent variable. That just means what's your input and what's your output. Okay, so you got to look at the chart to determine that. All right, so what do we think? What's going to be our input? What's going to be our input? Okay, yeah, how do you know? Yeah, it's a great way to think about it, right? It's on the x-axis. That's going to be our input value. If you think of it in terms of the independent and dependent variables, right, the price depends on the weight. All right, so we're going to create a table and do a verbal representation. I'm going to help you start the table. So we're going to do a table that's similar to the one with the movie tickets. Okay, so we have the weight. That's measured in pounds. That's like our X value, our input value. And then we have the price per pound, and that is measured in money. How many sections should I divide this into? 3. Why? Yeah, there's 3 pieces. 1, 2, 3. Now, I know that one looks thicker than the other 2. I don't know why. It really does not mean anything. Do you guys remember in geometry that points don't take up any space? Same thing happens with the line. It's just on the part there. Okay, so with the weight in pounds, let's look at our first interval. So we're going to start at 0. And then it goes up to 2, but it doesn't include it. So because we're dealing with the weight, we can write 1.99. Usually in terms of pounds, like they'll do to the nearest tenth or the nearest hundredth. Okay, and then the price per pound, look at your Y. So this is on the 8, so it's going to be $8. This one has a closed circle, so it's going to start at 2, and then I want you to fill that in, and then fill in the price. Okay, and if you feel like you can do the last one, that's fine. You can definitely do the price for the last one. And then I want you to start thinking about your verbal description. So use the first one as a model for how you want to set that up. It's going to be very similar. They're all constant values. Okay, and you should definitely be able to get your prices there, okay? Okay, so for the second one, it's 2, and look at these. They're going by 2s, right? Okay, 2, 4, 6. So this looks about halfway. So where would that be? Yeah, be about at 5. Now, I can't put 5 here because that would mean it would include it, but the open circle means that it doesn't include it. So what did we put here? Awesome. Okay, and then the price is on our Y. So the price would be how much per pound? Great. All right, now the last one, we know it starts at 5, and then this is just going to continue. So you can say 5 and up, or 5 and above. Did some of you put 5 to infinity? Yes. Okay. I would accept it. Okay, and then how much was that price? Yeah, $5. So again, it's in between there. Okay, great. All right, so now we're just writing a verbal description of this. So this is telling you that if you buy less than 2 pounds of the mixed nuts, then the cost is going to be $8 per pound, right? Yes. So I don't know if a lot of places do this now. I know there are like some markets where you can just scoop them and it weighs by the pound. Yes, exactly. I wasn't sure if you guys got out that way, the 4 ounce. Okay. I know some places they have like, you can measure out your own like peanuts and then you can make peanut butter in the store. Don't some of the stores do that? Yeah. Yeah, like maybe Whole Foods and Foods for Living, somebody said. Oh. I remember when I was little, Meyer actually had a bunch of bulk candy. I don't think they have that anymore.
I remember they used to have like those hanging scales.
Yeah.
I don't know if they do anymore.
I don't think they have like the candy though. I mean, it's probably not very sanitary. You have to be like wrapped candy.
It definitely does.
So they want you to buy more, right? So it's kind of like the logic between like the Sam's Club and the Costco. Like if you buy more, your price per unit is cheaper. So like if you aren't buying very much, they're going to charge you more. But if you buy lots of it, then they'll give you a discount. It's like, okay, if you buy, like people will do buy one, get one half off, right? Or like buy two, get one free. It's so that you buy more of the stuff. Like maybe you just wanted one box of crackers, but they're buy two, get one free, so you're like...
So then you have 2 more boxes of crackers
I
than
know.
you actually want. Then they get stale and you're covered in
Exactly.
So it's like when they do, like, 1 for $1, like 4 for $3 or something.
Yes. And like Meyer now, I don't know if you guys go grocery shopping, but they used to be like, 2 for $7, but if you bought one, they'd still give you the price of $3.50. But now there's like little writing that says when you buy 2 or more. So they'll give you the discount if you buy more of them. The more things they sell, the more profits they get. I know.
Because they do like a lot of sales where it's like 2 for $7 or 1 for $4.
Yes. Like buy 2 for $10 or buy 1 at regular price. No. If you spend $50, you get free shipping. See? Yeah, that's how it works. So the last 2, I combined them together. So I said for 2 up to 4.99 pounds, the cost is $6 per pound. For a purchase of 5 pounds or more, the cost is $5 per pound. Buy more, save more, right? But only if you're going to use it. And then once you have your verbal description written, I want you to look at the form of a piecewise function, because that might be something that you've never seen before. Notice there's a fancy bracket. We're going to be making those today. Okay, notice the form is a little bit different, right? You have inequalities built in to the function. So piecewise functions are going to depend on intervals. Okay, so when I say intervals, I'm talking about the inequality. Okay. Okay, so for the next one, we're going to evaluate for 2 different values. So it says for x equals -1 and x equals 4. What you have to decide is what equation to use within the piecewise function. So sometimes the 2 of them fit into one equation. Other times it might be the first one and the second one. Okay? It really just depends on what your piecewise function is. Okay? So we're evaluating, which means generally when you are evaluating, you are plugging something into a function to find a numerical answer. So we're going to be plugging that in. And this time we're doing it twice. Okay? So for our notes, I'm going to give you some helpful extra things, and then I'll tell you what I expect to see on your homework. So this is 2x plus 1 if x is less than or equal to 2. Notice that this says h of x equals, and then you have these fancy brackets here. Okay, so this is if x is less than or equal to 2. This is if x is greater than 2. So when you're deciding which one to use, just ask yourself, is -1 less than or equal to 2? Yeah. Okay, so since -1 is less than or equal to 2, you are going to use 2x plus 1. That's where you're going to substitute. So it's all based on which one does it fit into. Okay? When you substitute 2x plus 1, it's just going to be 2. We're going to substitute plus 1. And then there is a special way we're going to write it out. Okay? So when you plug in -1, and we're not going to use calculators today because this is mental math. 2 times -1 is -2 plus 1 is... Okay, now the way that we're going to write this is in function notation. Notice that this says h of x. So it's h of, what did I plug in? -1. What was my output? -1. So it just so happens for this one that my input and my output are the same. So h of -1 equals -1. All right, now I'm going to do something similar for x equals 4. Again, I just asked myself, is 4 less than or equal to 2? Nope. Is 4 greater than 2? Yep. So because 4 is greater than equal to 2, you're going to use x squared minus 4. All right, so when you're doing your homework, you don't have to write this note out. I do want it in your notes so you understand why you use that part of the function. And then we're just going to plug it in. So we have x squared minus 4. X squared minus 4. We're going to plug in 4. Okay, and then, Adam, what did you get for that one?
12.
Okay, and then let's write it. Do you guys feel like you can write it in the function notation without me? Okay. Great. All right, you guys want to do part B on your own? Okay. So now yes, use the same x values. Yep. Now you have your g of x. And then feel free, if you finish that, to go to the one below. All right, so x equals -1. Did that go into the top equation or the bottom? Yeah, because -1 is greater than or equal to -2. So you have to use 2 to the x. What is 2 to the -1? All right, awesome. So g of -1 equals 1/2. That should be your final answer. Okay, what about for 4? 4 is greater than or equal to -2, right? So you had to use the same equation. Okay, so you had to use the bottom one for both of them. That's fine. You don't have to use both of them. Okay, so then, yep, this one's g of x, so this will be g of 4 equals 16. Okay, what questions do you guys have for me on the evaluation piece? Okay, so now what we're going to do is we're going to be graphing, and we do have to remember a couple things that you learned in Algebra 1. So one thing you learned in Algebra 1 is how to graph inequalities. So do you guys think that you could graph those on a number line? Do you guys remember that? We can just do... Okay.
I think I just need to
The arrow goes in the direction of
It does, as long as your variable's on this side. One of my students taught me that. Okay, so if you have a 2 here, right, 1, 2, 3. So if it is x is greater than or equal to 2, what kind of circle do we have? Yeah. And then because the variable is on this side, the arrow just goes in that same direction. You can also think, okay, what values are greater than 2? All the values that are to the right side, because you have 2, 3, 4. All right, so then we'll do x is greater than, just x is greater than 2. So how is my graph going to be different here? Yeah. Arrow going the same way? Yeah, because it's still greater than. Okay, so when it says what's the difference between the graphs, really the only difference is what? Okay, so we have a closed circle when what happens? Okay, so I'll say the difference is x is greater than or equal to 2 has a closed circle at 2, while x is greater than 2 has an open circle. And then it says summarize your findings. So let's talk about what symbols are going to produce what types of circles. We're going to need this for our graphs. So if it is greater than or equal to or less than or equal to, that's when you have the closed circle. And if you have greater than or less than, that's when you have the open circle. So when we start graphing, because all of the piecewise functions have an inequality, you are going to have some open and closed circles on the graph. Okay? And we'll talk about what that looks like. Alright, and then once you got that, you can flip it over. We're going to start graphing. When you are graphing, you want to span your entire grid that you have. And the grids that we have are 10 by 10s. Okay, so you want to make sure that you span that graph. Okay, and that's something that I want you to practice when you're doing that on your homework as well, because that'll be what you need to do on your quiz. Alright, so we're going to graph each function. You guys are going to write your first piecewise function, so we're going to make some fancy brackets together. We have g of x equals, now the fancy bracket, the arrow part of it, the pointed part, should go where your equal sign is, so it can look something like this. You guys can practice. Okay, so 1/4 x plus 3. Okay, so g of x is equal to 1/4 x plus 3 if the x value is less than 0. But g of x is equal to negative 2x plus 3 if x is greater than or equal to 0. Okay, now when you're graphing these, there's a couple things you want to keep in mind. Okay, the first thing I like to do is I like to know what my graph is going to look like, because we just talked about all these different types of functions here, and there's a lot of different looking graphs on this list. So 1/4 x plus 3 is what type of function? Linear. Now, linear functions can either go up from left to right or down. Do you guys know which one this is going to be? How do you know? Okay, good. It's a positive what? Yeah, so it's the slope. So a positive slope. So I put pos slope. When I was doing this for the homework, I would just draw the line. Like, you don't have to write out the name of the function. You can just tell me what it looks like. Okay, like this one is also linear, but it's going where? Down. Yep. So again, if I were doing this on my homework, just next to this, I would just put this line. Okay, but the reason why it's going in this direction is there's a negative slope. That's just a way for me to check to make sure that when I graph it, it looks like it's supposed to. Now, when you are graphing these, you have to pay attention to the key value. You guys have an idea what the key value is for this particular function? No? Yep. Why?
Because it's in the inequalities.
Yes. 3 is a good guess, because you do have, the 3 is the x-intercept for both of those. But your key value is always going to be what is with the inequality. Okay? Now, with the key values, you have to graph those for both lines. So what I do is I make a mini table for each one. So I'm going to make a mini table for g of x equals 1/4 x plus 3. And then we're going to do another mini table for g of x equals negative 2x plus 3. And we're using mental math, so we're going to keep some of those strategies in mind. This is what I mean by a mini table. We'll talk about different strategies you can use as well. So the key value has to be in both. So 0 has to be in both. Now sometimes that bothers people because they think, oh, but if x is less than 0, it doesn't include it. And that's true, but the way that we show that is by using what? What type of circle?
Open.
Open. So the reason why we have to use an open circle and we can't just start at another value is because, remember, in between any 2 points is how many points in between them? An infinite amount. Okay, so we just know this one's going to be an open circle here, and then whatever we get here, this is going to be a closed circle. Okay, based on the symbols. So let's actually plug these values in and see what we get. So if I plug in 0, what's my output? 3. Now if I want to figure out what else happens, just follow this. If x is less than 0, what's another value you'd probably try? Yeah, you'd probably try negative 1, right? Now when you plug in negative 1 times a fourth, you get negative 1/4. What's 3 minus a fourth? 2 3/4. Okay? Now that's going to be an estimation. I like to deal with whole numbers when I can. So what might be a good value to plug in? Yeah, negative 4. Why? Yeah, it's one of the multiples of 4. So what would be another good one? Yeah. And again, remember, it's a 10 by 10. So I just have to make sure I span out to negative 10, and that will get me there. So when I plug in negative 4 times 1/4 is negative 1. Negative 1 plus 3 will be 2. And then for negative 8, what will I get? Yep. And we are gonna graph this. So you have 0, 3, 1, 2, 3. Just put an open circle there. I know that one's a little harder to see because you're on 0. All right, and then -1, the 2 and 3/4, that's an estimation, so I'm going to focus on these. 1, 2, 3, 4. So at -4, I'm at 2, and at -8, I'm at 1. And this is where your straight edge is going to come in. So your straight edge is what's going to help you span the entire graph. Okay, and then you do put an arrow here because it is going to continue for all the values that are less than 0. How do you what? Okay. All right, now for the next one, I plug in 0, I get 3. Oh, the other thing I was going to tell you is if you wanted, after you graph 0, 3, you guys remember how you graphed linear equations back in Algebra 1? Yeah, with the slope, with the rise over run, right? So instead of going up 1 over 4, because that would be the wrong interval, you could go down 1, back 4. You could just do that. That'd be fine. You could do it that way and then just put that point in your graph, down 1 over 4. Okay? All right, now you have 0, 3. Let's pick some other values that are greater than 0. All right. So I want to span my graph. So when I plug in 1, -2 times 1 is -2. So I might want to go a little bit further to see where I'm going. -10 plus 3 is -7. Well, that's getting kind of close to my -10 edge. So I'll try 6, which is -12 plus 3, -9. Okay, that will span my graph. You don't have to do those exact points. You just have to do enough where you're going to be spanning the graph. So if you want, after 0, 3, this is -2, right? So could you go down 2 over 1? Yeah, you could do that. You could keep doing that. You could keep going down 2 over 1. Or you could just say 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7. And you could graph that point. And then at 6, I'm at -9. Okay, and then you can use your straight edge there. Now, there's a problem with this. Not really a problem, but a special circumstance. This is supposed to be a closed circle at 0, 3. I have an open circle. Okay, when that happens, here's what we have to do. If an open circle and a closed circle overlap, if an open circle and a closed circle overlap, you need to keep it closed. So the closed trumps the open circle. Yep, so we're going to fill it in.
Just a reminder to please choose the E in your attendance for today. If you forgot to do it this morning, please go back and redo it for us with the E for enrolled for the first day of second semester. Thank you.
All right, so we are going to close that circle, okay, and then we are going to connect those points with our straight edge, okay. Sometimes people, they try to make a target. I think just, we love target, but there are no targets here, okay, because sometimes people are like, oh, there's a closed circle and an open circle. I'm just going to put one around the other. Don't do it. Do not do it. Okay? What's that? No. Okay, so the closed trumps it. Okay, so the closed circle will fill that one in. And then the other thing I was going to tell you is when you see this in your textbook, it would look like this. Sorry. I want to get the slope right. It would look like this. Like you would not see a point there. Because remember, points don't take up any space. So when you see them on a graph in your textbook, you won't see a point. But it will just be closed in. Another thing is the open circle circle is only here. I remember in the past sometimes people would make all of these open circles. That means there'd be holes. There should be no holes in that graph. Okay, so it's just a closed one. Okay? Those are just some common mistakes to watch out for. All right, you guys ready to graph the second one? All right, let's do it. So, more fancy brackets. This one is called f of x. So this one is 2 if x is less than negative 2, and x squared minus 1 if x is greater than or equal to negative 2. Okay, so can you guys label what each type is and put what it looks like? All right, Evan, do you remember what the first one's called? If it's just the f of x equals 2?
Constant.
Yeah, the constant. Okay, so if it's a constant, it is a horizontal line. Great. All right, and then Julia, what about the second one? What type of function is that? Yup. And if it's a quadratic, do you guys remember what the graph is called? Parabola. And is this one opening up or down? Up. How do you know? Yeah, positive a value. Okay, great. Now remember, we are only graphing parts of these. So the line's not going to go forever. The quadratic is not going to go forever. It just is going to be on a certain interval. Okay, so really for this one, we're going to write out the type of circle and stuff, but when you do this, you really only need your key value, because if it's 2, okay, my key value in this case is negative 2, because that's what's in the interval. So that means negative 2 has to go on both of your tables. So usually I put that in first, so I know, hey, I got to have negative 2 on both. Okay, you have to have the key value on there. The other values, you can choose what they are as long as they're in the interval. Okay? Now, the top one, Augustine, is that going to have an open circle or a closed circle? Is it going to be open or closed? Open. Good. So I'm going to write that down. Open circle, which means this one, because it's equal to, has to be a closed circle. And sometimes I just do this, like I put a closed dot there. I like that verbal reminder because I like to do my tables first and then do the graphing. And so I don't want to think about that part again. But if there's no place to plug this in, that's okay, because at negative 2, what's your f of x value? Yeah, it's just 2, right? And then let's pick values that are less than negative 2. So at negative 3, I'm at 2. At negative 10, I'm at 2. So really, for that one, it's the key value that matters. And then you're going to draw your line going to the left. So you have negative 2 here. This is 2. So I have an open circle at negative 2, 2. And then I don't even need to put those points on there. Anytime it's a straight line, just go ahead and follow your grid. Okay, and then for the next one, it's quadratic. So if it's quadratic, I like as many points as possible so I can get the shape. Okay, or else like mine becomes kind of shaky. So if I plug in negative 2 squared is 4, 4 minus 1 is 3. Now this is greater than or equal to negative 2. So the next number I'd want to plug in is, I like to graph them all. So I'm going to do negative 1, then 0. Okay, so negative 1 squared is 1. 1 minus 1 is 0. If I plug in 0, I get negative 1. If I plug in 1, what do I get? 0. If I plug in 2, what do I get? Okay, if I plug in 3, what do I get? If I plug in 4, I get, and that's off my graph, so I'm done. Okay, so all of those are going to be on my graph. Again, the quadratic is symmetric. So now I'm at 3, so I have a point right here. At -1, I'm at 0. At 0, I'm at -1. And remember, these are symmetric. So at 2, I should be at the same place. This is 3, 9, 8. And then when you connect these, you're connecting them with a curve. I like to do this side together to get that rounded value. And then I'm going to connect this side. There we go. Okay, so the only x value where you should have 2 points is at the key value. Nothing else should be overlapping, okay? So the lines of each function, they should never intersect or overlap. If you have this like going through, that is a problem. Okay, you should not have that. Okay, and then your graphs for this section need to be on graph paper, so I'm going to come around and pass them out if you need them. And then remember that with your homework, this is submitted in Google Classroom. So we're going to look at the calendar. Okay, so this is due tomorrow at 7:40 in Google Classroom.